Steve's Physics channel. I'm Steve, and today we have a pretty classic projectile motion problem. For this problem, it's a cannon shoots a cannonball with an initial velocity of 40 meters per second at an angle of 38 degrees. We want to know what is the hang time, the maximum height reached, and the range of this particular shot. Go ahead, pause the video, try it by yourself, and when you're ready, I'll show you how I did it. Welcome back. Hopefully this is pretty straightforward. But first thing I did was I always like to write off to the side all the things that I know about the problem. So in this case we know the initial velocity, we know the angle, and gravity, because we're on Earth, and we know what we're looking for in terms of hang time, height, and range of the shot. Another useful thing to know would be to figure out the components of the initial velocity, so the x and y components. And actually that'll be my first step. I want to find the horizontal and the vertical components. To do that, you just need to multiply the initial velocity times the sine or the cosine, depending on whether you want the horizontal or vertical component. For this problem, when we do that, we find the horizontal component is 31.52 meters per second and the vertical is 24.62 meters per second. And now you have a choice as to what you want to solve next. For me, I decided to find the maximum height next. To do that, I used the equation final velocity squared is equal to initial velocity squared plus 2 times gravity times height. Now, you know when it's at its maximum height, the final velocity is 0 because at that point it has no velocity in the y direction. So final velocity is 0, initial velocity is what we found before, and we know the rest. So we just plug it in and we solve for height, and in this case we get 30.93 meters for the maximum height. Now we can use that to solve for some of the other unknown variables. Next, I found the total time that the cannonball was in the air. To do that, I use the equation height is equal to initial velocity times time plus 1/2 at squared. In this case, we're looking in the y direction, so a is gravity. And we know everything in here except for time, which when we plug everything in, we get a quadratic, which I know is a little annoying to solve, but when you do it, you get that the time is 2.5065 seconds. However, that's only solving for the time it takes from the launch to the top of the flight of the ball. To find the total hang time, we need to double it because it's half the time to get to the top and then half the time to come back down. So when we double it, we get the total time is 5.03 seconds. And now we can use that when we're solving for the total range. This one's actually pretty easy. Range is just equal to initial velocity in the horizontal direction times time. Now we already knew the horizontal direction's velocity, and we just figured out time, so we just multiply those two together, and we get that the range is equal to 158.55 meters. Hopefully that wasn't too bad. If you do have questions, please leave them in the comments below. And if you like this video or found it helpful, please like and subscribe for more content just like it. And in the meantime, have a great day.